reminder to, there it is. We are recording. So as a reminder to everyone, this is part 2 of our workshop series. We had part 1 yesterday. We hope some of you were able to tune into that, where we had 11 of our semi-finalists pitch their proposed projects for Scaleup. Today we have 12 semi-finalists, so this is a new cohort group, different from yesterday. Before we dive in, though, James Zaylor, Associate Director for Tech to Market, has some welcoming and open remarks. So, James, the floor is yours.
Thank you, Mary. Excuse me. So, acknowledging that that many of you may have heard something not a whole lot dissimilar from what I'm about to say yesterday, I will try to keep this relatively brief. First and foremost, I want to thank everybody for being here. We're really excited about Scaleup. We're really excited about these projects that you will be able to see today. I want to thank the folks here at ARPA-E that have made this possible, Mary for sure, but also our leadership that helped us to kind of get this across the line and get this program launched. So just a little bit of background for the one person on the line that isn't familiar with ARPA-E or hasn't heard this already. So ARPA-E is kind of the DARPA of energy. We have kind of a threefold mission, or 3 main guiding principles: energy security, energy technology leadership, and emissions reduction associated with the use of energy. And unlike our forebear over at DARPA, we don't have a built-in customer. We don't have control over the acquisition of our technologies. We have to operate within the marketplaces that exist and within the policy frameworks as they exist. And we create possibilities there that ultimately have to find their impact in the commercial space. And we've run, in ARPA-E's history, many programs. I believe that we're up to now, over 60 programs, or around 60 programs. More than 800 or so projects have come through the ARPA-E portfolio. So we have a really sizable selection of technologies that have been demonstrated kind of at the feasibility level. And we realized a couple of years ago that as we were growing as an agency and as we were kind of facing the challenges associated with getting these technologies all the way to the point of impact in the marketplace, we realized that there were some gaps in the way that we were funding things. And last year, kind of in the lead up to the summit, we started to ask the inventor and the investor community about their interest level in something that looked a lot like Scaleup. So through an RFI, through a roundtable session that some of you may have participated in at the summit last year, we began to formulate a vision for what this is. And that's all culminated here in a program that was launched in December of last year. We've made a couple of twists and turns around cost share and cost share timing and even the size and speed of the program. But ultimately, the mission has stayed the same, which is to continue the support of those feasible technologies in terms of demonstrating their viability for the marketplace and for the investor. And a critical piece of that is engaging with you, the investor and industry community that are the customers, the acquirers, the investors that will help these guys get to the next level of their development. And so that's what today is all about. So Mary's going to take you through a more substantive overview of Scaleup and dates than I just gave. And then we're going to hand it over to the performers, and they're going to show you what they've got, tell you about their technology in a very brief overview, kind of a elevator pitch with a slide, and then we'll ask you to connect with them to learn more and to see how you could be a part of their effort in this very exciting program. So without further ado, I'll hand it over to Mary.
Thank you, James. So yes, as James said, I'm Mary Yamada. I'm a tech to market advisor at ARPA-E. I've been working a lot with Scaleup. So this is very exciting for us, for me, and hopefully, I imagine, for all of our semi-finalists that are presenting today. So just to dive in to our agenda. So James graciously gave us welcoming remarks today. I will be your friendly MC for the day. So I will talk to you guys a little bit more about what Scaleup is. We'll do a brief intro to the semi-finalist cohort. We'll talk also about the Launchpad. So hopefully some of you have had a chance to take a look at that already, but if not, we'll do a very quick tutorial. And then from there, we'll go into the pitches. As both myself and James mentioned earlier, this is part two. We had part one yesterday, and we recognize that some of you, this might be a little repetitive. So we're going to do a bit of an abbreviated version of the walkthrough today. And I would encourage everyone, we have the recording from yesterday up already on the Launchpad. So I'll show you where that is later. Please definitely feel free to dive into that material. We would certainly encourage it. So to start off with, let's just do a quick Scaleup overview. So Scaleup actually stands for Seeding Critical Advances for Leading Energy Technologies with Untapped Potential. So it is an acronym in true ARPA-E form if you are familiar. This is our first ever scaling and pre-pilot focused program at ARPA-E. So this is very exciting for us. The idea is that we want to take successfully funded technologies through our primary R&D focused programs that have developed successful prototypes at the bench scale and help them tackle new problems like manufacturability, reliability, creating additional performance data that will help them integrate technologies into greater systems, with the ultimate goal of hitting commercially available. We want these things out in the real world. This is a total $75 million program, so this is large by ARPA-E standards and large by really any standard when it comes to R&D focused programs. So this is very exciting for us. This is also a small business focused program. So in order to be eligible, you have to be in essence a for-profit entity. So either a small business, a corporation, or a consortia of business. And that is the majority of who our semifinalists represent, which is very exciting to us. Another key feature of Scaleup is that all of these semifinalists have to have partners. And this is actually a key stage, which I'll get into a little bit later. But and this is one of the main purposes of what we're doing here today, to talk to you, potential partners who could be customers, end users, suppliers of these technologies if they're successful. So without further ado, let's talk a little bit about where we are with Scaleup. And apologies, this slide is a little distorted for some reason, but I will walk you through it nonetheless. So back in December 2019 is when we launched the Scaleup program. We received over 200 applications, and we've actually narrowed this down to 32 semifinalists. So we are now in phase 2. Those semifinalists, they were notified in July, on July 8th. And here we are now. This is the virtual workshop series. As we mentioned yesterday was day 1, today is day 2. And this is actually a critical step for where many of our teams need to solidify and obtain partnerships in order to submit their full applications, which are due September 25th. Just as a note, LOI, that's letter of intent from partners, is kind of that critical piece that is needed by our semifinalists. That's actually a requirement of the Scaleup program. So just something to keep in mind from the partnering side there. From there, we'll move into finalist stage. So we'll narrow down our 32 into an even smaller pool, somewhere around 10 or 12. And then from there, we'll go into negotiations. So we expect all of this to start taking form in kind of January 2021. So that's kind of the timeline where we are now and where we're headed with Scaleup. So I know this is the moment everyone's been waiting for, so we'll talk a little bit about who our semifinalists are. So as I mentioned before, we have 32 semifinalists. We're very excited about them. 24 have agreed to make their status and project details public. So those are the different logos that you see here on this screen. About half presented their pitches yesterday and about half are today. And what we've tried to do is loosely bucket these teams into application spaces. So this is applications based on where their kind of project within Scaleup is focused. So we have projects focused on transportation, on buildings and agriculture. And this is a lot of the projects that you'll hear today. So you'll hear stuff on battery technologies, you'll hear stuff on radiative sky cooling and some agriculture technologies and sensing, which is exciting. So lots of different things within these spaces. Grid and renewables and industrial largely went yesterday. So again, encourage you all to check out the pitches from yesterday if you haven't already done so. And as here are just some of the technologies. So if we actually were to kind of take out those logos and put in some technologies in replace of them, this is roughly what you would see. So I mentioned some in the transportation and building space, but in grid and renewables, we also have things like grid edge software, lithium-ion supercells. We have methane leak detection in the industrial space, also low temp waste heat recovery. These are just to name a few. Like I said, we highly encourage you to check out the Launchpad, where you can learn more information on each of these technologies and the companies that are really behind them. To give you all a sense of what these projects are focused on within Scaleup. So I've kind of mentioned this a little bit before, but just to list it out plainly for you, a lot of these teams, a lot of these companies and startups, they're working on things like technology integration. They also want to build capacity. Validating performance is also key for many of these projects and teams. Manufacturability and making sure their technologies are reliable. These are all things that kind of encompass a project within the Scaleup program. And the idea is that we want these types of activities to enable substantial investment from the private sector community that can start to develop those early commercial products. So just to give folks on the line that have heard us say partner, partner, partner a couple times now, so what does that really mean? Well, we're pretty open to interpretation here, but this is just to give you some sense about the types of partnerships that could form with our semifinalists. So this could be a formal partner, so someone who is contributing cash or in kind, and this means you're investing in the technology, you're investing in the project and company. You could be providing a demonstration site or a facility. You could also be providing equipment or personnel. So lots of different options within the formal partnering space. In addition, you could be an advisor. So your guidance and expertise as being someone in industry, as a customer, as an end user, that's extremely valuable to these teams. So an advising partner is certainly a role to play. Another is an equity investor. So if you're a VC, this is something we are encouraging our semifinalists to pursue if it's right for them. So please definitely consider that as well. Also, if you're a potential customer, maybe you're not ready to partner now, but now's a good time to start looking at who these semifinalists are, because if they are successful, this is when their early commercial products will be hitting, sort of 3 years after their project starts. So, but never too early to start looking now. And I also want to just emphasize that our semifinalists within this cohort, they really do represent some of the top ARPA-E technologies, companies, and teams. So here at ARPA-E, we are extremely excited about them, and we hope you all will be too. Okay, so I did this yesterday. I went to the Launchpad. I exited out of PowerPoint, and it worked well. So we're going to try that again. So bear with me as I navigate to my internet browser. So as I mentioned, the Launchpad is live now, which is really exciting, and I hope some of you have started to explore what is there. So each of the participating semifinalists, they've created a profile, and it can be accessed through the Launchpad site. Ooh, this is very zoomed. Let me see if I can fix that. There we go. Aha, excellent. So this is just the standard ARPA-E web page. So you can see at the headers at the top here, there's one that says Scaleup Launchpad. Please click on that, and that will take you to the Launchpad site. Here we have information just to tell you more background on the program. So if anything that myself or James has said has led you to ask more questions about the program, you can certainly find answers to those here. So it'll talk more about Scaleup, of course, the workshop. So we already have the video here posted from yesterday. Please check that out. And then you can meet our semifinalists. So you can sort by different categories of technologies. And here, if you click on any of these, that takes you to their profile, where you can then explore more information, tells you information about their company, about their team, about what their proposed technology and project is, and then also information about what types of partners they're seeking. Each of these also has contact information, so please also feel free to use that if at any time you want to have a further conversation with these folks. So I'm going to navigate back to PowerPoint. Always tricky. There we go. All right. Aha. And I think I'm back. Amazing. Amazing this worked. I think it worked at least. Okay. So lastly, just to emphasize, as I've said several times now, yesterday was the first day, so focusing on the grid, renewables, and industrial technologies. Today, we have more of a transportation, batteries, buildings, agriculture focus, so quite an array of technologies today. And I think this is my last slide. So from here, we can move into the pitches, which I know is really the reason why most of you are here today. So without further ado, we are going to get started. So semi-finalists, I hope you're ready and waiting. And we're just going to start in alphabetical order here of the folks that are presenting today. So Sadhya Ravanendran of Autogrid is up first. She is the Director of Industry Solutions for Autogrid. Sadhya, can you hear me?
Yes, I can. Thank you, Mary.
Whenever you're ready.
All right. Well, the world's leading energy companies, both regulated and deregulated, are working with Autogrid to integrate all distributed energy resources, monetize new value streams, and drive deeper engagement with their customers. With our flagship Autogrid Flex platform, we have pioneered the science of energy flexibility management. Autogrid mines the rich data load from DERs and balances demand and supply in real time across a large network of these resources. Therefore, Autogrid is turning big data into power. One application of Autogrid's technology is in delivering virtual power plant solutions. Given that distributed energy is a primary market trend in the energy sector, virtual power plants with distributed energy resources, or DERs, are a pathway to large-scale, rapid, and transformational energy sustainability. The flexible capacity from distributed storage and electric vehicles alone is estimated at 104 gigawatts by 2023, nearly 10% of the generation capacity of the United States in 2019. The market for VPPs is here and now. Good afternoon, everyone. As Mary said, I'm Sadhya Ravanendran, Director of Industry Solutions at Autogrid. Today, I'm going to present to you Autogrid's Scaleup project on highly scalable virtual power plants, or VPPs, for mass storage and electric vehicle deployments. Since our initial ARPA-E award in 2011, Autogrid has made significant advances in our technology of the Flex platform. Flex is the industry's leading demand response and distributed energy resources platform. We have served over 40 customers and have over 5 gigawatts of flexible capacity contracted on our platform. With funding from ARPA-E, we plan to literally scale up the number of assets our platform can manage and co-optimize across value streams in real time. The goal is to increase this number from about 5,000 to 100,000 through the course of this project. In addition, we plan to adapt our core predictive controls technology for new use cases on EV fleet management. The optimization of an EV fleet has to account for the dual use of these assets for both transportation and energy flexibility. Therefore, we plan to deliver charge management solutions for EV fleets that focus on bill optimization value streams for fleet owners and leveraging vehicle-to-grid capabilities. Through our extensive partner network, we have identified commercialization and financial partners for our project. In addition to the ones listed on the slide, we look forward to partnering with companies that can bring scale. For example, EV manufacturers, fleet owners, and energy service providers. We look forward to the continued conversations. Thank you for the opportunity to present today.
Thank you, Sadhya. So next up, we have Harbing Liu, Program Manager with Cambridge Electronics. Harbing, are you here?
Yes, I am, and apparently there's a mistyped name of our company in this slide.
Oh, no, I'm so sorry. Oh, my
No
goodness.
problem. Please remember, this is Cambridge Electronics, everyone.
I apologize. Oh, my goodness.
No problem.
All right. Well, it's right on this slide. This is the slide you made. So.
Yes, yes.
All right. Whenever you're ready, Harbing.
I'm ready, yeah. Okay. Hey everyone, this is Harbing from Cambridge Electronics. We are a semiconductor startup company that aiming to transform the future of power conversion. So probably we know the electricity we use in electric cars, consumer electronics, or data centers require some sort of power conversion to convert the AC to their DC applications. And vice versa, we need to convert solar power from DC to AC to integrate it in the grid. The device that enables all this conversion is a silicon-based power transistor. And the market of this power transistor will achieve $34 billion in 2025. However, there are two major problems with this silicon-based power transistor. First, the device made of silicon are usually pretty bulky. Probably we all experience the hassle to carry a very bulky laptop charger in our bag, but the real problem comes for the electric vehicle and data centers when the converter or voltage regulator is very bulky. Their performance are significantly limited. The second problem is silicon is not that efficient. It wastes about 15 to 20% of the energy it converts. Worldwide, that equals to almost the total US residential electricity consumption annually. So our value proposition is to reduce the size of power converters to a tenth of its original form factor. And on top of that, we would like to reduce 70% of the energy loss. How do we achieve that? The key technology behind it is our proprietary 3D GaN technology. We first replace the material from silicon to gallium nitride, and this new material enables a much higher operating frequency than silicon. And the higher frequency it operates, the smaller size we can achieve. And on top of that, we introduce a three-dimensional structure, which we called FinFET technology, so that we can reduce the energy loss during its turn on and off operation to achieve our 70% energy loss reduction target. Right now, we have finished our pilot production in a US-based foundry, and next step, we would like to raise the fund for a full commercial production. Also, we are seeking new commercial partners that are interested in power conversion business. So please contact us if you are interested. Thank you so much.
Thank you, Harbing. Okay. Next, we have Will Northup, co-founder and CTO of Exergy Predictive. Will, are you here?
Yes, can you hear me?
I can hear you and I can see you. So whenever you're ready.
Okay, well, let's get started. So hi, I'm Will Northup, CTO with Exergy Predictive. We're a growing software as a service company with the goal to transform how data is used to manage energy in electric vehicles. Our exciting technology promises to enable rapid expansion of sustainable electric commercial trucks for last mile delivery fleets like UPS or Amazon. So we all know that e-commerce is a growing part of our economy, expected to grow about 37% in the next 3 years, which may be conservative given all the delivery activity with COVID-19. Fuel consumption from the last mile delivery segment is also expected to grow considerably. Just as an anecdote, Class 3 through 6 commercial vehicles make up 5% of the overall transportation energy landscape, and we estimate that if half of these trucks were electrified, it could save $22 million a day or $8.1 billion a year. So although delivery fleets have recently committed to future electric truck purchases, low range compared to fuel power trucks and high battery costs have been sources of resistance. So we've learned that data from these vehicles are not currently being effectively utilized to enable fleets to defeat range anxiety and eventually implement more of these electric trucks. So Exergy Predictive has developed machine learning-based connected energy management systems for electrified delivery vehicles to enable fleets to increase electric vehicle penetration. So our technology, developed in cooperation with University of Minnesota under a recently completed ARPA-E Next Car program grant, uses predictive data analytics and artificial intelligence to manage how energy is used in electric vehicles, similar to, say, how Target predicts customer purchasing decisions. So we take historical data from previous trips, along with exogenous data like traffic and weather, and use them in proprietary machine learning algorithms, along with physics-based models, to drive a more accurate range prediction. So our previous ARPA-E program resulted in 20% energy efficiency improvement in electrified delivery trucks in partnership with UPS and Workhorse, a growing electric truck manufacturer. So all electric vehicles already report an expected driving range in their vehicles. So you might ask, how can we provide additional value? Well, manufacturer range estimates are usually not informed by past vehicle data, so they can be inaccurate due to driver behavior or the vehicle is highly loaded or if there is bad weather. So we can use a bell curve or say normal distribution to illustrate how likely it is the vehicle can achieve the predicted range, like you see on the right. So if the vehicle manufacturer is the prediction is the mean value, there's some uncertainty about whether the number is accurate. So we can deploy a vehicle on a longer range, say, if using the technology. So with our algorithms, we can shift and shrink the uncertainty, increasing what we coin range confidence. So if the vehicle can't make it to the route, we can also calculate minimum amount of energy needed for on-route charging. So vehicle electrification saves energy and helps fleets meet sustainability goals at the same time. And we're rapidly partnering with delivery fleets and EV truck manufacturers to demonstrate our technology in use. So with further success in the field and some help from ARPA-E, we expect to secure some financial investment early in 2021. So with that, thank you for listening.
Thank you, Will. So next, we have Andrew Shea, co-founder and CEO of Feasible. Andrew, are you here?
Hello. Can you hear me, see me?
Hi, Andrew. Yes, I can. I can hear you and I can see you. So whenever you're ready.
Awesome. All right. Hi, everyone. I'm Andrew Shea, co-founder and CEO of Feasible. We are accelerating the massive shifts to electrified mobility by commercializing a technology that will have a significant near-term impact on the cost of batteries. This is crucial for our clean energy future, and it's an opportunity to create billions of dollars per year in economic value. So at Feasible, we're addressing battery cost in three main ways. First, by increasing how productively batteries are made. Second, by improving how efficiently batteries are used. And third, by making it easier to unlock the residual value of old EV batteries. And currently, we're focused on this first area of battery production, which really is the catalyst for the whole industry. So this is a great time to introduce you to EchoStat, our intelligent inspection platform that uses proprietary ultrasound technology to improve productivity by over 30% and more than double profitability for battery manufacturers. EchoStat consists of production-grade hardware that easily integrates into any customer workflow, electronics and sensors for quickly collecting rich ultrasound data on any type of battery, and software analytics that deliver valuable insights based on data streams from across production. In many ways, EchoStat is like a pair of magic glasses that give customers the ability to see batteries differently. It quickly uncovers internal anomalies that standard electrical and X-ray methods are unable to detect, and it can monitor dynamic processes that are critical to production quality, but are typically black boxes at scale. This is important because currently, most production issues are caught days to weeks after the errors actually occur. This is extremely expensive. In contrast, EchoStat can quickly detect upstream errors at their source. This creates a tighter feedback loop and has many compounding benefits, from faster time to market for new batteries, to accelerated yield ramps for new production lines, to higher steady-state productivity. Our techno-economic analysis shows that this productivity increase alone represents over $9 per kilowatt hour of value creation, which translates to over $18 billion per year by 2030. Our ultimate goal is to provide solutions for high-volume battery production, but success during scale-up could also lead to early commercial products for customers in process engineering. We've worked with major battery and EV companies in preliminary evaluations of our prototypes, and during scale-up, we aim to deploy our systems on pilot production lines to demonstrate the value of advanced process inspection in real-world settings. We're looking for additional partners, So if battery reliability and productivity is a competitive advantage for your company, or if you're an investor who's excited by industrial innovation and clean energy impacts, let's talk. Thanks for your attention.
Thank you, Andrew. Okay, next we have Mike Zimmerman, CEO and founder of Ionic Materials. So Mike.
Hello, can you hear me?
I can hear you, Mike. I can see you.
Okay.
And whenever you're ready.
Yeah, so thank you. My name is Mike Zimmerman. I'm the founder of Ionic Materials, and the vision of Ionic Materials is to create solid-state batteries that can be mass-produced, that are safe, that have very high energy density and extremely low cost. And the way that we are going to do that is we've developed the world's first polymer electrolyte that solves problems with polymers that hasn't been solved before. We've developed a polymer that conducts lithium ions at room temperature, and now we have a polymer that at room temperature conducts lithium ions at the same conductivity as a liquid electrolyte. Also, a problem that we've solved with polymer electrolytes is that we've been able to make them work for 5 volts up to 5 volts, very high voltages. And also a major area we've been working in is making our material such that it can drop into standard lithium-ion manufacturing with no changes to the manufacturing process. So our approach, unlike other solids, has been to drop into current lithium ions. And the advantage of it is the fact that our material is non-flammable, and it causes the cells to be very safe. Over time, we've demonstrated 2 amp-hour cells, we've demonstrated 10 amp-hour cells, we've demonstrated 17 amp-hour cells, and just this past month, we've built a cell, our cell partners built a cell that passed a nail penetration test at 30 amp-hours, which is very, very significant. So by having a cell such that it can be inherently safe at 30 amp-hours means in an automobile or an energy storage system, you can get rid of all of the systems level requirements for safety. So this allows, by having this polymer, this allows us to be able to make highly safe, highly energy dense, and very low cost batteries. We're scaling up this year. We've developed a pilot line that makes the powder. We're using essentially standard plastics manufacturing to make the material, and we've been funded by ARPA-E to make powder for high voltage cathodes and for lithium metal anodes, and we're scaling up this powder this year with a pilot line. And the purpose of applying for this grant is to be able to scale up that powder to high volume manufacturing and to really enable the next 3 years the industry to use Ionic Materials solid state batteries to revolutionize the automobile industry and the energy storage industry. Thanks a lot for your time.
Thank you, Mike. Okay. So next we have Gregory Hitz, founder and CTO of Ion Storage Systems. Gregory?
Yep, can you hear me?
I can. So whenever you're ready.
All right, hello everyone. I'm Greg Hitz, the CTO and one of the founders of Ion Storage Systems. We are commercializing a new solid-state battery architecture that was invented at the University of Maryland by Dr. Eric Waxman under the ARPA-E range program. Dr. Waxman solved the hardest problems in solid-state batteries by developing a multi-layer ceramic electrolyte that enables high-loading lithium metal anode with high-rate cycling and no external volume change. By combining these attributes with all non-flammable components, we're releasing a product that's completely safe with competitive rate performance that operates from below room temperature to beyond 90 degrees Celsius and surpasses the energy density of anything on the market. So high-performance batteries are a $35 billion market that's projected to grow rapidly to $100 billion by 2025 and far beyond after that. And so as we're asking more and more of our batteries, we increasingly find that traditional lithium-ion technology is holding us back and customers are demanding something better. Electric flight needs better energy density, ships and submarines need better safety, electric vehicles and grid storage need to stop wasting round-trip energy efficiency and engineering effort by air conditioning their batteries. At Ion Storage Systems, we're answering this call by providing a battery that's safe, high energy density, and does not require a cooling system. And we've been busy transitioning this technology from lab to a commercial product. We're currently scaling up production and implementing industrial production philosophies in order to deliver pouch cell samples to interested partners in the second half of 2020. Our first product offering is going to be a roughly cell phone-sized battery, which integrates chemistries already demonstrated in the Watson lab. This Gen 1 product offers unmatched performance characteristics, and our technology roadmap goes far beyond. We have a strong team in place to accomplish this, and we're led by CEO Ricky Hanna, who we recruited in 2020. He has over 20 years of experience in the battery field, including VP of Worldwide Operations at Valence Technologies, CEO of Electric Vehicles International, and Executive Director of Battery Operations at Apple, in which he led a new battery scale-up every single year. We've started the commissioning phase of a 20,000 square foot facility outside of Washington, D.C. to service our first market defense and aerospace customers. These are performance-driven customers that are more able to match us with products that critically need our performance and suit our initially small production volume. And as we grow to larger volumes, the advantages of our technology will be matched by the economies of scale to hit the sub $100 per kilowatt hour price point required by electric vehicles in the grid storage market. We are in discussions with customers in every single one of these markets that you see on the slide, and we'd love to include you in our upcoming sample evaluation program. We're also looking for partners in material suppliers, manufacturing deployment, pack development, and anyone else who believes in our mission and wants to join us. Again, I'm Greg Hitz, CTO of Ion Storage Systems. Please visit our website, www.ionstoragesystems.com, and thank you very much for your time today.
Thanks, Greg. All right, so next we have Greg Rieker, co-founder and CEO of Launchpad. Greg, different Greg.
Great. Yep. Yeah, do you have sound?
I do. I have sound and I can see you.
Great. Okay. All right. Well, thank you, Mary. I'm Greg Rieker. I'm the co-founder and the CEO of Launchpad Technologies. We're a Colorado-based startup that provides continuous real-time methane monitoring of oil and gas infrastructure. What we've created is akin to a methane radar. We use a single eye-safe Nobel Prize-winning dual-comb laser developed right here at University of Colorado, where I was a professor, and place this in the center of areas of dense oil and gas activities. The laser uses hundreds of thousands of wavelengths of light to detect tiny part per billion changes in methane without ever needing calibration. We combine this laser system with real-time wind data in software that autonomously and continuously locates and sizes emissions in near real time on well sites within a 10+ square mile area. There are lots of methane detection technologies, and the question always is what sets us apart. The difference is that this system continuously monitors, where nearly all technologies today are snapshots in time. With a snapshot in time, you get the equivalent of a single frame of a movie. And if you take any single frame from the middle of a movie, it's very hard to tell what's happening because you don't have the context around that frame. Knowing what comes before and after that single frame is critical to understanding what's actually happening in the movie. Oil and gas is no different. In oil and gas emissions monitoring, context is everything. There are leaks. There are also regular process emissions. There are leaks that start and stop. There are process emissions that are due to upset conditions on the well pad that come and go, perhaps due to a design flaw or other factor. If I fly over or drive by and get a single snapshot, I have no idea the context of the picture I see. If I have a continuous monitoring technology like this, like ours, I get a full movie worth of context, so I can make a much better decision about how I'm going to handle what I'm seeing on the ground, how to put people out in the field to go after that leak, that emission. Are we getting traction? 116 grueling milestones in our original ARPA-E program, which I know is not unique to us, have ensured that we are. Under the ARPA-E Monitor program, we underwent 2 rounds of third-party blind testing with stunning results. We've completed a number of pre-commercial pilots and now have our first commercial deployment. That customer is expanding their initial order by a factor of 3 with plans for more. Under Scaleup, we will achieve the first continuously monitored oil and gas basin, scaling to hundreds of square miles of continuous coverage to prove the gains that are possible from an industrial and a regulatory standpoint with this technology. We're currently looking for additional oil and gas deployment partners in the Western U.S. to join the team. We're also securing a strategic and venture investment round to complement this scale-up round. And we're talking with OEM suppliers, precision optomechanics. So if any of this is interesting to you, I encourage you to reach out to me at greg.reeker@longpathtech.com in the upper right corner there. Thank you so much.
Thank you, Greg. Hey, so next we have Dave Hansen, co-founder of MicroSeries.
All right, can you hear and see me?
I can.
Great.
Yep. All right. Whenever you're ready, Dave.
All right, hi, I'm David Hansen. I'm the co-founder of MicroSeries, and I'm excited to tell you today about our new technology that helps grow crops using less water, less energy, less labor, and makes them taste better and get higher yields. The problem that we've identified is that our needs for water are increasing while the resources for them are decreasing. And so farms use enormous amounts of water to grow things that we really like, including beef and biofuels and tomatoes. And this is done a lot with center pivot irrigation systems. In 20 million acres of U.S. farms use these systems, and this infrastructure provides a real opportunity to fine-tune irrigation and reduce water use. The challenge is really understanding the plant's needs well to do that properly. Currently, people use timers or use soil sensors that work okay, so long as the soil sensor is actually near the roots in the right locations. But they've been shown that if you actually measure the plant, it works a lot better. And the problem with that is it's really labor intensive. You have to go out in the field and cut leaves off of plants, which is destructive also. So our solution for this is to make micro sensors that you can see in my fingers there in the middle of the screen. And we put these micro sensors directly on the plant. So the plants wear them. They're connected via wires to the plant impedance analyzer that we've created. And this continuously monitors the water status of the plants. It can track them as they approach wilting, as they go past wilting and into death, and avoid those things by, say, turning on the irrigation. More interestingly is that you can actually give plants a little bit of water stress. This is called deficit irrigation, and it's been shown to improve flavor and increase yield in many crops. And so we could do this really well with our continuous system. We've put these sensors on many plants, including fruit trees and strawberries and tomatoes and sorghum, and it works on all of them really well. Our plan here is to take these wired sensors and make them into a distributed network of microsensors to break into the $60 billion global market and reduce water use, reduce energy use, because even running the pumps to spread that energy, to spread the water, takes a lot of energy. And we're looking for partners to help with wireless networking, techno-economic analyses, and marketing, as well as other end users to join our team with Bayer, Crop Sciences, NextState, Macrofab, the University of New Mexico, and Sandia National Labs. If this is interesting to you, please contact me, David Hansen, at microseries.com. Thank you very much.
Thank you, David. Okay. So next we have Eli Goldstein, co-founder and CEO of SkyCool. Eli.
Hey, Mary, thank you. So I am the CEO and co-founder of SkyCool Systems, and we are commercializing a truly passive technology that uses the sky as a renewable resource for cooling. And it's all enabled by a thin film coating we developed with support from ARPA-E. Our films can stay cooler than the ambient air temperature, even when they're under direct sunlight. And so we apply this film to a rooftop panel, which you can see here, and use it as an add-on to reduce electricity in air conditioning systems by as much as 40%. We can even use panels to replace air conditioning systems and save much more, removing the need for refrigerants and compressors. Our panels have a form factor similar to solar panels, such that we can leverage the existing infrastructure to mount and install panels on roofs, But the panels have the key advantage that they don't have electrical interconnects. There's no need for UL certification. They're about 50% lighter and save twice as much energy when connected to persistent cooling loads. Our beachhead market is commercial refrigeration systems, and we've validated the technology in this segment with 3 commercial deployments. We completed our first deployment earlier in January of this year, and it showed 550 kilowatt hours per meter squared per year of electricity savings. We're deploying our second supermarket deployment later this month and have 2 more planned by the end of this year. And with support of this Scale-Up grant, we hope to have many more done in 2021 and 2022. For our ARPA-E proposal, we're working with 3M, a strategic film manufacturing partner, to scale up the next generation of our films. And the goal is to manufacture 10,000 square meters of film and make 5,000 panels. Additionally, we're going to work with key channel partners, including Trane Technologies, multinational air conditioning company, large ESCOs, including the Angie Group, to reach customers, and then also major supermarket chains to deploy panels with refrigeration systems. And then finally, the grant will be used to optimize our supply chain, train installers, and then work with additional channel partners in the HVAC and efficiency space. Beyond supermarket refrigeration, we can use the films on a number of outdoor applications to reduce cooling loads on buses and vehicles and outdoor electronics. If you'd like to learn more about the business model scale proposal, please send me an email at eli@skycoolsystems.com or visit our website. Thank you.
Thank you, Eli. Next, we have Doug Campbell, CEO of Solid Power.
You seeing and hearing me okay?
I am, yes. Let me get to your slide.
Welcome to our new normal.
Yeah, exactly. Whenever you're ready.
Yep, absolutely, yeah. So thanks for everyone's time. Really honored to have the opportunity to brief you on what we're doing here at Solid Power. And to that end, so we are an industry-leading provider of all solid-state batteries. And I think some of our prior peer companies have talked about the value proposition of all solid-state being high energy, high safety, and at the end of the day, low cost. And I'll touch on a little bit about specifically what we do. We're about a 6.5-year-old company, originally born out of the University of Colorado Boulder. And today we're in a 30,000 square foot facility in Louisville, Colorado. Headcount's approximately 60, and that's spread between 3 divisions. R&D, obviously our sort of legacy group, but really where a lot of our growth has been on more manufacturing and quality. And that really segues into what is the sort of cornerstone of our business operations, which is our megawatt hour scale roll-to-roll production line. And that was really one of our original hypotheses with Solid Power, is that we wanted to focus exclusively on solid-state batteries that could be manufactured in a manner that looks virtually identical to today's lithium-ion. And indeed, we were able to validate that. So in other words, we start with materials in powder form, process as a slurry, coat using conventional coating and systems, densify using conventional calendaring systems, etc. We do work exclusively in sulfide solid-state batteries, and the reason for that is we feel that it has the best blend of performance and manufacturability, performance being things like ionic conductivity. Sulfides have by far the highest levels of ionic conductivity over any solid ion conducting material. And then their relative malleability, low mechanical properties, is what allows them to be compatible with a megawatt hour scale or with a roll-to-roll production line. The pilot production line that we have installed is suitable for supporting qualification through what's called the B-sample phase. That's roughly about halfway through the automotive qualification phase, where you would successfully leave B-sample phase with a full design freeze. And that really segues very nicely into our ARPA-E project. The ARPA-E project really is intended to facilitate that objective. And so we have partnered with our auto OEM partners, including BMW and Ford, where we would transition from the cells that we're producing today. We call them our pre-A samples, which are 20 amp hours, and we would transition to a 100 amp hour cell, which would be our formal A sample, which our objective is to start the production and qualification of that in January of 2022. Yeah, with that, pleased to brief the ARPA-E audience and others, and look forward to further developments. Thank you.
Thank you, Doug. So next we have Charlie Murray, CEO of Switched Source. Charlie?
Hi, can you hear me all right?
I can hear you and I can see you. So whenever you're ready.
Perfect. Hi, everyone. My name is Charlie Murray. I'm the president and founder of Switched Source. Here at Switched Source, we make power electronics equipment for distribution utilities. And we're really focused on three things: how we can improve the reliability, the efficiency, and the solar hosting capability of the distribution grid. Now, utilities are facing a number of challenges today. They're facing challenges around aging infrastructure, challenges associated with reliability of the grid, and then also challenges associated with incorporating more distributed generation, like rooftop solar and electric vehicles. With all of these in mind, utilities are looking at mobilizing up to $1 trillion in capital over the next 10 years to modernize the grid. And what we're trying to do here at Switched Source is provide them that next generation of distribution automation equipment that's based on the power of power electronics. So the background on our technology is this is a power flow control device. It was invented at Michigan State University. And what's really clever about this is we are using a cascaded modular architecture. What that means is we are taking very basic building blocks that use commodity components, and we are just stacking them in a clever way and using advanced controls so that we can use these lower cost components to connect directly to the types of voltages that distribution utilities use for delivering power to us every day. So Michigan State was able to bring this to a beautiful prototype stage. We licensed that technology here at Switched Source, and we developed a company around that technology. We worked with a number of OEMs in the utility equipment space, along with a couple of utility partners, and we developed our first MVP, a minimum viable product, which is the picture that you see in the lower right-hand corner here. Now, to give you a sense of where we connect into the grid, we've got a couple of pictures on here. I'm not going to walk through these too much, but suffice it to say that utilities have set up the distribution grid in a way that's easiest for them to manage. It's really a hub and spoke type system where they're delivering power down individual distribution circuits. What's great about the way that utilities have set up this system is that there are existing locations out on the grid where we can bolt on our equipment and become this new control point, where we can act more like an internet router for power for the electrical grid. Now, as part of Scaleup, what we're planning on doing is taking our technology and really illustrating the value of our equipment for different use cases, for reliability, for solar, for other things associated with power quality and energy efficiency. Right now, we are interested in finding additional partners that can support us in terms of the deployment and development of this technology. Feel free to reach out to me if you have any questions or would like to learn more. Thank you.
Thank you, Charlie. All right. And now we move to Sam McLaughlin, who is an internal research manager with Volvo. So Sam, can you hear me?
Yes. Hi, Mary.
Hi, Sam.
Hi. Well, welcome to my summary of our proposal for energy conservation and optimization technology for the Mack Truck brand. Yes, my name is Sam McLaughlin. I'm a research manager in our Chief Technology Office here. Greenhouse gas emission reductions are becoming urgent for the environment, but of course trucks are vital to the U.S. economy. In 2014, 3 million barrels of oil per day were gulped by medium and heavy-duty trucks. These trucks account for 20% of U.S. transportation emissions today and could grow to 50% by 2040. So we have a challenge ahead of us. For the commercial truck segment, we must accelerate both fuel economy improvements and low-carbon solutions. The Ecotech cloud-connected vehicle software suite will reduce medium and heavy-duty truck fuel use by a minimum of 15%. That's equivalent to 220 million barrels of oil annually. This is accomplished by the interaction between connected system data, traffic volume, topography, etc., and control of the vehicle powertrain. The Ecotech team will build on 2 prior ARPA-E projects which have successfully bench-tested the software suite IP. In this project, we will mature the control algorithms to operate in our vehicle by using lab-based powertrain testing and simulation, combined with customer validation of the truck. This graphic on the right is from a prior ARPA-E project and describes how the intended control algorithms will interact. Control and feedback from the lower-level engine and accessory components, like air compressor and HVAC systems, will communicate with transmission, vehicle, and cloud-based data banks to determine the optimal operation for each control layer. Finally, the team leverages existing technical expertise and successful previous research collaborations. Our software solution goals will be proven cost-effective, due in part to remote upload capability of software, which allows enhancements to be programmed over the air. And also, product reliability will be improved via the interaction of our partners if this project moves forward. What we're still looking for is the right customer fleet that's interested and capable of performing the validation testing. And we have a cash cost share opportunity of $1 million for an investor. I hope I've convinced you of the need, value, and confidence we have in providing these important benefits for the U.S. truck fleet and its customers. Thanks.
Thank you, Sam. All right. So I want to thank all of our semifinalists for their pitches today. Thank you so much. And thanks to everyone who was able to tune in today. I just want to remind folks very quickly to please visit the Launchpad. We have the link here. You can access it easily from the ARPA-E webpage and use it to connect with our semifinalists. So all of their contact information is available on that page. So please feel free to explore that, learn more. We hope this was a good, enticing start to some conversations with the semifinalists that presented today and then also yesterday. James, anything else, closing remarks for today?
Yeah, I will. Let me make myself known here. I will say the same thing I said yesterday. I mean, thanks to everybody who joined us. And especially the pitchers, especially the folks that helped to make this happen at ARPA-E, and then of course all of you on the line. I'll also emphasize again, please connect with our applicants here. That your participation in their projects will make their projects better, and at some level it's essential because it's a requirement. You've about a month and a half left to do that, so use the resources here to do that. I also said yesterday, and I'll say it again, it's a crying shame we can't do this in person. We had certainly intended for that to be the case, and that has the benefit of allowing us to interact with all of you. We definitely want you to engage with the Scaleup participants, but we also want you to engage with us. So feel free to reach out to me, Mary, anybody here at ARPA-E anytime to give us your thoughts on Scaleup, your thoughts on this workshop, and your thoughts on what we're doing in general. You know, we're here to work together with you guys to achieve the impact that we hope to see in the real world. And yeah, and your input and your engagement is essential for that. So thanks again to everybody online. Thanks again to Mary for running the show here. And we hope to see you guys connect with all of these applicants.
Yeah. All right. Thanks. Thanks, everyone.
Thank you.
Bye-bye.
So long.